Assalamualaikum warahmatullahi wabarakatuh. To TS and Ciahwi Zudin Ihsan. We are from Group 5. Today we will present about CNC milling and lathes. Basically, our project refer to exercise 3. My name Nuhani Syara binti An Shizuki and I am with 4 another members. Mama Azri, Siti Nur Amira, Humaira and also Fakhruddin. For the methodology for milling process, first we would draw the 2D drawing according to the instruction or according to the exercise. Okay, so this is the step to be drawn to creating a toolpath, which is set up for including the stock setup. In this part, we use 20 mm flat end mill for the cutting tool, and then setting to remove material using dynamic mill. We use 20 mm flat end mill for the cutting tool, and then pocket outer center use cutting tool 5 mm flat end mill, and then remachine the pocket using 1 mm flat end mill. So all the toolpaths and all the details according to the exercise tutorial 3. So this is the workpiece material for CNC milling machine, include metals, plastic, wood and composite. So for the result using Mastercam software, on the left we can see the toolpath group. There is 4 set of toolpath group, and the middle picture is the 2D drawing, and on the right side is the final product of milling machine, milling Mastercam simulator. Okay, so this is the G1 code that I have generated from the Mastercam software. So I would like to pass this presentation to Azri.
Assalamualaikum. I will explain briefly for methodology for LATHE. We download the design for LATHE in the link provided and enter it in Mastercam. The data taken are all referenced through tutorial provided and many are the same. The only difference is the tool used, data depth, angle, chain and more. Before facing, we change the important data into the box provided such as program, calculation, duplicate tool, stock setup and margin. And then select the tool or the rough right negative 80 degree tool and enter. And then 80 millimeter diameter spot drill from the tool list with depth negative 3.0. And then 50 millimeter diameter and mill from the tool list with depth also negative 3.0. Okay, from the can group, select rough and select the two entities, which is entity A and entity B. In the tool path parameter tab, we choose the ID rough min 16 diameter 80 degree. Select the chain finish and select the ID finish 16 diameter negative 55 degree tool and retract clearance is 0.1. Select the entry point or chain the inner boundary with two entities A and B. Select the OD right 55 degree in lead in out, change the right angle and also length. Use stop for outer boundary, plug parameter also change. After changing in the chaining box and select the OD to finish the right tool, 35-degree tool, change lead in out and for lead in angle and also for plug parameter also change. After that, for groove and choose chain, select the entry point or change the inner boundary, select entity A. From there, we need to change the arrow to move, which is the green arrow, and select the OD groove center medium tool from the tool list. We need to edit tool, change the style to single and insert thickness and insert geometry section. In parameter, change the composition, and then in groove shape parameter, use stop for outer boundary. Okay, next, groove finish parameter, change the direction for first pass is CCW, and then turning groove in general, choose chain and then choose the right entity for A and B. Create new tool and choose grooving, edit tool, choose single N, and insert geometry and holder geometry. Parameter, we composition and setup tool and choose plug tool and click at the right entity. We choose rough and cut direction is negative in groove rough parameter. Groove finish parameter, we choose CCW. We setting the lead in and change the right angle in first and second pass. Next slide. Okay, this is figure of tool that we use and the change process. Next. Okay, this is figure of data that we key in. Okay, let's. Okay, this is the process from phase until the cut off. And last step, we choose the cutoff and click at the endpoint and choose the OD cutoff, right? We select all operation and verify and we'll see the cutoff process here. And then lastly, we select all operation and click on G1 and choose NC file. And after that, the NC program will appear in our screen. Next.
I'm going to explain about the discussion. From the result of part drawings and programming, several findings should be highlighted for this project. First, for exact toolpath, dimensional accuracy and surface polish, part drawings must be accurate and detailed. 3D modeling tools help see and analyze the turning process by representing workpiece geometry. Annotating essential features improve toolpath development and eliminate errors. The study found that optimized tool routes and programming improve turning operations. For optimal material removal, surface finish, and tool life, spindle speed, feed rate, and depth of cut must be chosen. Turning tool geometry, inserts, and coatings effect machining efficiency and precision. Adaptive roughing and finish profiling in Cadcam software lowered cycle times and increased productivity. Okay, for the recommendation for this project, our students need to plan and identify the scope of the project in order to effectively plan the project. That must first clearly identify the scope of the project, which should include its objective, requirement, and timetable. Make sure it is familiar with the capabilities as well as the restriction of the CNC machine that will be utilizing. This include having a firm grasp on the maximum cutting size, the spindle speed range, the various tooling CAM program that dependable and well suited to its requirement, so that it generate toolpath and G code. That's all from us. Thank you.